All right, hey y'all, it's Miss Summers with your notes today on graphing in science. Make sure that you have our essential question written down. This is what we're looking at today. Why do graphs need certain elements to be helpful? So, especially if you're a freshman, today's focus, we are looking at how graphs are constructed, what they need in them in order to be useful. Because in my experience, I see a lot of high school freshmen, they come in and they're not 100% sure, if I give you a set of data, how does it go on a graph? What is the graph supposed to look like? We want to make sure that all the graphs that we produce are nice and easy to read, that they show what our data says. So, first things first, the purpose of a graph. Follow along on your little outline thingy. So a graph is used to visualize data. It makes it easy to see and draw conclusions. So if you look at a spreadsheet full of numbers, those numbers might not jump out at you as saying one thing or another. But if we put it in a picture, it becomes a little easier to see what the numbers say. So for instance, take this fine little graph, this fine little bar graph. What does it show? Well, we have different sciences, biology, chemistry, physics, and earth science. And we have numbers here on the side that say number of students. So maybe this is a school and these are the number of kids taking each class. Well, what can I see? Well, hopefully what you see is a whole bunch of people are taking biology and earth science, and very few people take physics for some reason. Okay, so why is that helpful? Why is that good to know? Think about it in a school setting. Maybe this would tell the person in charge of buying stuff that, hey, we need more biology supplies, or we need more biology textbooks, or we only need one person to teach physics, and maybe they should also be able to teach earth science. So they are very practical. All right, so let's carry on. That's what we use graphs for. Let's look at types of graphs. There are more graphs than this, obviously, but these are the two that we're going to primarily see in earth science. Excuse me. We have line graphs and bar graphs. So the main difference between a line graph and a bar graph, all right, is whatever the independent variable is. If the independent variable is quantitative, that means it's a number value. So temperature is a number, time is a number, depth is a number. That would be a line graph. All right, I could continue on with the graph forever and ever. This is generally the one we're going to use. But that doesn't mean bar graphs are bad. Bar graphs are just fine. They just show us different information. With a bar graph, we're comparing groups. We'll use this when the independent variable is qualitative. So remember, qualitative are descriptions. So let's say I'm comparing, the type of test compared to grades. So multiple choice test is one group. Short answer test is another group. A mixture between some multiple choice and some short answer, all right? Those are not things that are numbers, they're words. You would use a bar graph then. So let's just take a quick look-see-loo at two graphs and what kind we would use. So I pose this question, how does temperature affect the rate of a chemical reaction? All right, so the first thing you need to do, identify the independent variable. What am I going to change? Will I change the temperature or the rate? So temperature is my independent variable. Therefore, I'm going to use a line graph. So I can see here when the temperature is low, there's very little reaction. As the temperature increases, the reaction goes up to a certain point and then it goes back down. This number down here, your independent variable is down here on this part of the graph. All right, let's take a look at another one. What kind of graph for this one? Which teachers give the most homework? Which teachers give the most homework? So, what is the independent variable here? Is it the teacher or the homework? Does the amount of homework change what teacher you have, or does the teacher you have change how much homework you get? The answer is the teachers. Who the teacher is the independent variable, and that's a quality. Therefore, we'll use a bar graph. So here we have Ms. Smith, Mrs. Williams, Ms. Jones, and Mrs. Brown. And you can see they've included these little keys here. Ms. Jones likes to give homework on Thursdays. On Wednesdays, Ms. Brown gives the least homework. That's what that graph is saying. So, you'll need to be able to figure out what graph to use in certain scenarios. If we're doing a lab and we are graphing, I'm asking you to graph the data. Ask yourself, what was the independent variable? Is it a number? I'll put it on a line graph. Is it a group? I'll put it on a bar graph. So, before we move on any further, I want us to look at this graph right quick. And I want you to tell me what it's about. Close that door. You don't need to go to physical science class. All right. So, hopefully what you've determined is, Miss Summers, I can't tell anything with this graph. And you'd be quite right. Because there is no information on it. This is just a bunch of lines. This is just a bunch of bars. It doesn't mean anything. This could be class averages on tests, like first block, second block, third block, so on. This could be, I don't know, like favorite kind of fruit, like apples, bananas, oranges, whatever. We don't know because I'm not given any information. We want to make sure when we make a graph that it is complete. So you need four things on each graph. And it is imperative for your assignments, okay? I expect you to include all these things. Thing number 1, a title. I take off points if you don't put a title. All graphs have titles. Just like the title of a book, it shows you what it's about. And it gives you kind of an idea of how to read the graph. And it doesn't have to be a fancy title. Just rephrase the research question to a statement. So here, the dependence of traffic ticket cost on automobile speed. So the traffic ticket cost depends on the speed. All right, well, if the speed goes up, it looks like you get more, your ticket costs more. Over here, comparison of dissolved oxygen in local streams. So each of these bars is a different stream. This one has the most oxygen. Looks like this one has the least. Thing number 2. I'm a real stickler on this one, friends. I'm a real stickler on this one. Labeled axes. You can't just put numbers on the side and call it a day. I got to know, what did you change and what did you measure? So the x-axis, that's the one down yonder, down here, is the independent variable. So here, plant growth over time, I waited a certain number of weeks. My y-axis is the dependent. The number of weeks I allowed to pass changed how much growth there was. Obviously, the longer I let it go, the more it grew. Over here on this one, if this thingy would go away, it's not going to go away. Is it going to go away? Probably not. It says the number of bubbles produced per minute by plant X in various depths. Okay? The depth there along the bottom changes the number of bubbles per minute. That's how you can tell variables based on a graph. Number 3, a key, if you need it. Not all graphs need keys, but some of them do. Okay? If you have 2 groups that you're comparing over time, so let's say here, monthly rainfall. Okay? Time is a, what's that word? Quantitative measure. So like I could continue this graph on throughout the year. But I have 2 cities. So I'm going to compare them. So I can say city B is warmer in March, but it's cooler in May than city A. Number 4, numbers on the graph. All right, most people are pretty good about putting numbers, but we want to make sure that they're evenly spaced. So if you start at 0 and then go to 2, your next number should be 4 and then 8. So you follow a pattern. And here's the big one, guys. most of the graph is used. Don't use just the itty bitty baby part. Okay? If you have a whole sheet of graph paper, don't do that. Use the whole space that you're given. It makes it easier to see if there's a difference. If you smush all your data into like this one itty bitty little corner, first off, it's super mega hard to read. And second off, if there's any change, it's going to be next to impossible to see. All right, so that concludes what we need. We need a title. We need our axes labeled. If we need it, a key. And we'll need our numbers. So with that being said, I'm going to let you go with this practice. You have a couple of practice before you start your assignment. Part of it is interpreting this graph on atmospheric carbon dioxide. All right, I'm going to let you go. If you have any questions, you let me know, and I will get back to you as soon as possible.